The last thing we need to talk about with regards to sequences are actually called series. And that is when you sum the numbers in a sequence. Okay, summations. We use the Greek letter sigma to indicate that we're doing a summation. You might have seen this Greek letter in the Excel program, if you use the Excel program on the computer or on your iPod. You add the numbers in the sequence together. So we're summing the numbers, and when we do that, we call it a series. Okay, so here's what the notation might look like with this Greek letter sigma. That's not a very good one, but it'll work. Again, we have an index number of sorts that tells us where to start and end. This is the number where we start. This is the number where we end when we're adding these numbers together. So let's suppose that our sum tells us to add the numbers in a sequence. The k refers to the fact that we start by plugging in this 1 for k. Then 1 goes up to 2, and then up to 3, and then up to 4, and then up to 5, till we get up to the number n. And we just simply add all those numbers together until we get to whatever number they've told us to add to. Okay, let's do an example. If we have k equals 1 to 24, and our problem is negative k. That means we plug in 1, so we get a negative 1, and then we plug in the next number 2, so we get a negative 2, and we plug in the next number 3, so we get a negative 3, and we're adding all those numbers up through negative 24, because the last number we plug in is a 24, and this makes it negative, because it tells us to, okay? So that gives us an answer. So I'm just kind of showing you what these sort of look like here. Here's a different one. If we have k equals 1 to the n power of 1 over k, that would mean we plug in 1, so 1 over 1 is 1. We plug in 2, so 1 over 2 is 1/2. Plug in 3, and we keep plugging in the numbers till we get to whatever the last number is. Sometimes the last number is actually infinity, and we keep going forever, which seems a little weird, but we will talk about that in some of the stuff we're doing. Okay, here's just a third quick one. I'll just make sure we're getting how to plug this in. If I have k equals 1 to 9, and my summation is for k squared, I just plug in 1, so I have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared, and I want the total of what that whole thing adds together. Well, these can be kind of long, right? So mathematicians have figured out some properties that can make them, some of them, a little bit easier, and we will learn specific things in the next 2 sections for what you need to know. So here's some formulas that you should be able to find in your book. I'll probably give you a copy of this on Monday just to kind of help you out, but some different formulas to refer to make things a little bit easier. So if you're just adding up a whole bunch of numbers one after another, here's a formula you can use instead to hopefully make it a little easier. Or like here's the squared one. So the one we just barely did, let's look at that one since it was k squared and it was 1 to n. So the formula's right here. N times n plus 1 times 2n plus 1 over 6. Okay, so for this particular number, the n value was 9. So we're going to go 9 times 9 plus 1 times 2 times 9 plus 1 over 6. So that gives us 9 times 10 times 18 plus 1 is 19 divided by 6. That's now something we can put in our calculator. So we have 90 times 19 divide that by 6, and it says that our total should be 285. If you want to verify that answer, you could do the problem. 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64 plus 81, and see if you actually do get that total. It should work out, and I don't want to take the time to do that on this video. Okay, a couple more quick examples using the formulas. I know I'm going kind of fast, hopefully thinking you can pause, and it's Friday afternoon and I want to go home. Okay, so if you look at the sheet of formulas that I'm going to give you, you can use this. There's a property that says if this is 3 times k, you can just simply take the 3 out and multiply it times the sum of just plain old k. And then you look at the sheet of formulas I gave you, and there's a formula for k, which is n times n plus 1 over 2. And we'll learn more about that formula another day. Okay, in this case, n is 5. So we're going to go 3 times 5 times 5 plus 1 over 2. So that is 5 times 6 is 30, divided by 2 is 15. So 15 times 3 is 45. So that one should add up to 45. Okay, let's try one more. If we have k equals 1 to 3 of k third plus 1, now this one's only 3 terms, so it's probably easiest to just add it out. So I'm just doing this to help you see how to use the properties. So it would be this property here, k cubed, plus the property for just adding that. So the formula for this one would be 3 times 3 plus 1 over 2 squared. I'm assuming that's n times n plus 1 over 2 squared. And then the formula for this on our properties is 1 times 3. Don't worry, you're not going to have to memorize these formulas. Like I said, this section is an introductory one. It ends up that we are going to learn some straightforward formulas, and you don't need to panic about knowing all of these properties for this test or for the final. And actually, we don't have another test. We just have the final. We're just learning a few last things before the final. Okay? Like I said, I know I kind of rushed through that. There's examples in your book you can maybe look at closer, and we will answer questions in class on Wednesday.